Let's talk about something that feels a little bit like magic, but is actually pure science. GPS. How does this thing really work? How does it find you all the way from space? Well, we're gonna break it all down.
I mean, just stop and think about that for a second. Right now, the phone in your pocket, or maybe in your hand, it knows your precise location on this planet. It's kind of wild when you really let that sink in.
And we're not talking about just getting the city right or, even the street you're on.
Nope. It knows your exact position, down to just a few meters. But here's the kicker. The really mind-blowing part is where that information is coming from.
It's being beamed down from satellites that are flying 20,000 kilometers straight up. So the question is, how on earth is that even possible?
All right, let's get into it. To figure this out, we have to understand what GPS really is. It's not just an app on your phone. It's this huge, invisible system orbiting way, way above our heads.
At its heart, the Global Positioning System is basically a network of satellites. And all these satellites are doing is constantly broadcasting two really simple things out into space: what time it is and exactly where they are. And this isn't just a couple of satellites. We're talking about a whole constellation, at least 24 of them zipping around the Earth at all times. It was originally a US military project, but now, lucky for us, it's free for anyone to use. They're all arranged in a very clever way so that no matter where you are on the planet, your phone can always see at least 4 of them. And here's the secret sauce. Every single one has a hyper-accurate atomic clock on board. Now this is a really important thing to get. Your phone isn't sending any signals up to the satellites. Not at all. It's completely passive. It's just a listener, a receiver, quietly picking up these signals, and then doing all the math itself to figure out where you are. Okay, so if your phone is just listening, how does it turn a simple time signal into a location on a map? Well, the whole system is built on one really elegant principle: converting a measurement of time into a measurement of distance. It's all based on this simple bit of physics you probably learned in school. The signals from the GPS satellites are radio waves, and we know exactly how fast radio waves travel. And that speed is, of course, the speed of light. It's a universal constant. So if your phone can figure out the time part of that equation, how long it took for the signal to get from the satellite to you, then it can easily calculate the distance. It knows exactly how far away that satellite is. But of course, one satellite isn't enough. I mean, knowing you're, say, 21,000 kilometers away from one point in space just means you could be anywhere on the surface of a giant, invisible sphere. We need to narrow that down a lot. So how do we get from that massive sphere down to a single point? Well, we just add more satellites to the mix. And this is where a cool geometric trick called trilateration comes into play. It's actually pretty straightforward. One satellite gives you that sphere of possibilities. You add a signal from a second satellite, and now you have 2 spheres intersecting. Where they overlap, that creates a perfect circle. So you're somewhere on that circle. Then you add a third satellite. That third sphere will slice through the circle at exactly 2 points. And usually, one of those points is a reasonable spot on Earth, and the other is way out in space. Your phone can pretty easily guess which one is you. So, okay, 3 satellites, 2 points, 1 obvious answer. In theory, that should be enough, right? But it's not. If you ever look at a GPS app, you'll see it's almost always locked onto 4, 5, even more satellites. So why the extra one? What problem is that 4th satellite solving? Well, the answer, funnily enough, goes right back to time. The whole system, as we said, depends on ultra-precise timing. But there's a huge weak link in the chain, and it's the cheap little clock inside your phone. Just think about this for a second. The satellites have those ridiculously accurate atomic clocks. Your phone, it has a simple quartz clock. And because radio waves travel so insanely fast, if your phone's clock is off by just 1 millisecond, 1,000th of a second, your calculated position would be off by 300 kilometers. I mean, that's not just a little wrong. That makes the entire system completely useless. And that is the genius of the 4th satellite. Its main job isn't really about your location. It's about time. See, with 3 satellites, your phone is trying to solve for 3 unknowns: latitude, longitude, and altitude. The signal from a 4th satellite gives it a 4th piece of data, which lets it solve for a 4th unknown. And that unknown is the exact error in its own clock. It basically lets your phone constantly sync up with the atomic clocks in space, which is how a cheap device in your pocket can be so incredibly precise. So we've got the atomic clocks, we've got our 4 satellites. We should be good to go, right? Well, not quite. There's one more really bizarre wrinkle that engineers had to iron out. And the solution, believe it or not, comes directly from Albert Einstein.
This is, for my money, the coolest part of how GPS works. It turns out you can't build a system this precise without accounting for Einstein's theory of relativity. Two different parts of it, actually. First, there's special relativity. The satellites are moving really, really fast, and that makes their clocks tick just a tiny bit slower. But then there's general relativity. The satellites are way up high, where Earth's gravity is weaker, and that makes their clocks tick a little bit faster. So you've got one effect slowing time down, and another speeding it up. It turns out the gravity effect, general relativity, is a bit stronger. When you do the math, the net result is that the satellite clocks get ahead of clocks down here on Earth by about 38 microseconds every single day.
Now, 38 millionths of a second, that sounds like absolutely nothing, right? But it's not. If the engineers just ignored this, the location errors would pile up at a rate of about 10 kilometers per day. The whole system would be useless in less than a day. So what do? They use one of the most brilliant engineering fixes ever. They intentionally build the clocks to run slow here on Earth, knowing that once they're launched into orbit, Einstein's relativity will speed them up to the perfect rate. It's just amazing.
So because of all this, GPS has become way more than just a way to get from point A to point B. This incredible planet-spanning system for keeping time has basically become an invisible utility, a global clock that our entire modern world runs on. And why does that matter to you? Well, that super precise time signal is the secret ingredient in so many things we take for granted. Cell phone networks need it to pass your call smoothly from one tower to the next. The global financial system uses it to timestamp billions of transactions. Even our power grids rely on it to stay synchronized and prevent blackouts. It's not just about maps anymore. GPS is how the world stays in sync.
So the next time you pull out your phone to look up directions, just take a second to think about what's really happening. What feels like magic is actually one of the most complex and brilliant engineering systems humanity has ever created. A fleet of satellites equipped with atomic clocks, all accounting for Einstein's theories of relativity, all of that working in perfect harmony just to tell you one simple thing: where you are.